let's get started. Okay, so last time we talked about reading files in Java. The rest of this week we don't have slides, so it's going to be a lot of live coding. Yay. I don't get enough live coding in, so I'm always excited when we get lectures. As a quick reminder, I say this every live coding lecture, but bless you. For when I do live coding, there's no fixed thing that we have to go over, that we have to cover, so I'm more open to questions and getting off track and derailed. If there are any questions that will help you get through the homework assignments, especially, I want those questions so we can talk about those specific things. Left to my own devices, I'm going to cover what I think will help you through the assignments the most, but if that's not what's actually going to help you, I'd rather get your questions and know what's actually going to help. Because there's no strict concept that we really need to cover, technically. I guess that's not really fair. It kind of is, but I guess it's not a concept, but I do have to show you how to even do this stuff. I guess it's kind of conceptual. Anyway, let's just get into it. So we want to talk about reading files, and I'll write some code that reads files, but the biggest thing, the focus that I want to have is how do we test methods that use files. And for some of this, I have the tests already up. I used to do this completely live, but when I'm writing a method like this live, it just takes up time without, okay, now I'm going to assert that the regions are the same. So some of it I already have pre-written, so we can just get rolling a lot faster. So the big thing that we want to talk about is reading files and testing with files. And I'm going to use this cities.csv file that has information about cities with their location and population. So with this file, we have the country code, the city name, the region code, which is a string, even though most of them are numbers. When I used to use this data for a homework assignment, and I'd trip everybody up. They'd look at the first two lines of the file, and they're both numbers, and they'd say, region is an int. It's not an int, it's a string. For example, it's Buffalo, New York. NY is not an int. And I'd always get the number format exception. This is a string. Anyway, populate, it's a lecture example now, so nobody's going to make that mistake because you're not coding with this unless you want to. Population, this one is an int, and then latitude, longitude as doubles. And then we have lots of data. The whole reason to have files and write software in general, at least in my opinion, I'll qualify this a little bit, in my opinion, is when you have a lot of work to be done, when you have a lot of data. For most things that we've done up until this point, except for some file I.O. in 115 as well, the problems are small enough that you could get out a sheet of paper and a pen and figure it out. Like when we're doing BSTs with 10 values, you could just sort those on paper. You wouldn't even use a computer for that. Where computers really start to give us an advantage is when we're no longer doing this by hand. I'm not even looking through this whole file. I don't even feel like scrolling through this whole thing. When we have almost 48,000 cities of data here, 48,000 lines of data, I'm never going to do anything with this by hand. I'm not going to look through anything or do any calculations by hand. Even when I want to find data, if I want to find Buffalo, I'm going to use my search feature. I'm never going to scroll through this and find any information using this data. I want to write software to go through this for me and use software to process this information and do any of the things that I want to do. Anything I want this information for, I'm writing software for it. But this is a lot of data, and we have to handle this data some way. So let me get the setup out of the way. We're going to need a few classes to store this information. I have different types. I have multiple values, and I want to store them in one object. I'm going to create a city class so I can store name, region, country, population, and then location, which is another object which has latitude and longitude as doubles. And I have getters here. I'm getting warnings on my code because I didn't write any, bless you, I didn't write any setters, so it's saying you can have these as final. You can use final here and have these be constants. Because I didn't write setters, I just don't need them for the example. But these are my objects that I'm going to use. So let's get those out of the way. When I say the city object, this is an object of this type. That's what I'm talking about. And what we want to write, the one we'll write today, I doubt we'll get to country population, but if we get there today, we'll get there and we'll do it. But this is the one that I want to write. I want to take that file name and process all of the information in this file. I want to get all of the information in the file into a data structure. And we have a few options of what that data structure should be. We could create just an array list of cities, and that'd be fine. But I'm going to take it one step further and create an array list of cities for each country. So I'm going to look for countries and have a hash map of country code, that 2-digit country code, to an array list of all of the cities in that country. So each time I read a line, I'm going to get that country code and add that city to the appropriate array list for that country. So that's what I want to do in this method. Before we start writing that, I want to talk about testing the method. I have some test cases already made because I don't like doing these test cases during lecture either. Is the big point that I want to make as well is I'm not going to test with this file. The 3 files that you're given in task 6, I almost said the wrong task number. In task 6, the 3 files that you're given, there's a lot of data in there, and you're not going to use those files as your test inputs and check to see if what was returned by the method returns all of that data in a data structure. Because you have your 3 methods, they're all going to read in a whole file and return a data structure with all of that information. You're never going to take that entire file. Those files are large, and similar size to this. Some of them are smaller, but thousands of lines. And you're never going to write a test case because your expected data structure is going to be absolutely massive. And you're not going to write that test case. You don't want to. I don't want to write those. Nobody wants to write test cases like that. So we need to do something else. But we do need to test with files because we have a method that we're testing, and the method takes a string, which is a file name, reads the file, and returns some information. So we have to test with files, but we don't want to use these data files that we're given. So what we'll do, pretty simple solution, is create smaller files. I'm going to create subsets of these files as my test files. So my very first test case, I'm just taking one line out of that file, one line of data. I always like my first test case to be the simplest possible one. I've said this in lecture a bunch, but my first test case, I want it to be I'm blanking on the word, but my indicator that something massively went wrong. If I can't get the right solution on this input, I know my code is completely busted. Like, there's no chance that it's correct. It's completely wrong, and I have some work to do. If it's wrong on a more complicated test case, this will be my second test file. If it's wrong on this one, I could have some obscure bug. I could be missing an edge case. Something different can go wrong. I have multiple cities in a single country. I might be doing something wrong with that, the way I handle that. A lot can go wrong here. But if I get this one wrong, I know I'm just fundamentally on the wrong track. So I like having an easy test case that's my indicator of, hey, something's really wrong. And then if I get that one right, I have my tougher test cases, which is, hey, you have a bug, but you're on the right track. So I always want my first test case to be very trivial. So cities test 1. I'm going to call my method with that file name. And for testing in 1.16, all your testing, put your test files in a subdirectory named data with all lowercase letters. Very unfortunate, last semester, I had a student in office hours, spent weeks always getting errors in Autolab. They had capital D data, and that was their issue. It has to be 4 lowercase letters, lowercase d, lowercase a, lowercase t, lowercase a, data. That has to be your directory name. And then in Autolab, I look for that specific directory name so I can grab all your test files. So if you name it anything else, I go to grab your test files and I don't get anything because they're in a directory of a different name that doesn't follow the homework spec. So make sure it's exactly that. And then whenever you have a file name, when you're running your code in IntelliJ and when it's running in Autolab, The path is relative to the root directory of the project. So when you're reading a file, it starts at the root directory of the project, then the data directory, and then / whatever file name you have. So this file name, data / cities test1.csv, this is what all your test files should be. Obviously, you can name your files whatever you want, but they need to start with these exact 5 first characters, data all lowercase, / and then whatever you named your file in that directory after that. If I try to do just cities test1.csv, I'm going to get file not found because there is no file named cities1.csv in the root directory. It's going to look in this directory. It sees the get ignore, the pom.xml, and nothing else. Everything else is a directory. It's not going to find a file with that name. So data / cities1.csv. Then I'm going to call my method. This is going to be a static method in the countries example class. So countries example.load countries, I can call the static method through the class, not through an object of that type. So I don't have to create a new countries example object. I'm calling it through the class because it's a static method. And give it the file name. That's going to give me my actual, that's what the method that I'm testing returned. That's what the actual value is that I need to test and assert that it is what I expect it to be. Then I'm going to create my expected hash map. I always like to, when I'm testing values, data structures, or objects, or whatever else, I'll create my expected and my actual, and then compare the two to see if they're the same. I recommend you do the same. If you're following the testing utility methods, you'll end up doing the same, testing the same way. Highly recommended. I've seen way too many students lose credit and even fail the course because they try to manually test everything without doing this approach. And finally, I'm like, I'm doing these testing utility methods, so you have to do it the right way and hopefully not fail. And then I'm going to call my helper method to compare the two data structures and make sure they have all the same values. Any questions on this so far? Yes. Like this, you mean? Yeah. It'll do the same thing in this case. Well, I'm not going to be able to tell because my method just returns nothing. But this will do the same thing. Dot means the current directory that you're currently in. So this will mean the current directory, which is already this directory, and then / data is going to go to this directory. Very much different than this. If you have a leading /, this is going to go to the root directory of your file system, which is not what you want. And this is going to break completely. But with the ./ that's fine. And with no /, the ./ is kind of implied when you have nothing in front. Okay, and then I expect a hash map of the data from that file. It's going to be a hash map with US mapping to an array list with just one city, which is going to be Buffalo with all of this data. So I only have one line. I expect one city in my hash map with one key value pair. And when I go to test cities 2, same setup, same structure, except I'm going to expect 2 key value pairs for my 2 countries, and then those 4 cities in the correct locations. This is what I'm expecting for that one. And then my helper method is going to take care of it from there. This is the way I always like to set up my test cases. I want generating a new test case to be as simple as possible. I should have to specify the inputs, the expected outputs, call the method I'm testing, and then pass it off to some helper method and let the helper method do the rest. I don't want to have to do any more work than that, and that's what I got this down to. I'm creating my expected, which is most of the work here, creating my input, calling my method, and then passing it off to my helper method. So I've minimized the amount of work I have to do to create a new test case. In this case, it still is a decent amount of work. I have to create a new file and then populate this data structure, which gets tedious. But I got it trimmed down to only the required stuff. If you're not using a helper method and you have gobs of code that you're cut and pasting, it's just too likely to make cut and paste errors, make little mistakes, little typos. I've seen it way too many times. I've done it way too many times. use your helper methods. It will save you a lot of time in the long run. So let's take a look at what this helper method does, because we have a little bit of a decently tough situation. We have to compare two hash maps to see if they have all of the right values. And hash maps have no sense of order in them. So we have to check if they have the same keys and values, the same keys mapping to the same values without any concept of order. So we can't do our array list thing where we iterate over the indices, pull the values of each index, and then compare them, which we will talk about as well in this example. So the way I want to do that is, one, check if they're the same size. I say this a lot. I don't think I said it enough this semester, but if I have two data structures that I'm comparing and they're not the same size, they're not the same. They're not the same size, fail, done, right away. Absolutely done. If I have a hash map or an array list, I have a size method. Call that size method. If they're not the same size, you don't have to do anything else. If they're not the same size, they definitely don't have the same data because they don't even have the same number of elements. Like there's nothing you even have to do after that. If they are the same size, this isn't formatted. If they are the same size, I'm going to iterate over my expected. Very important that I'm iterating over my expected. I guess not very important in this case, but I always like iterating over my expected. I'm going to iterate over my expected, and that's going to give me all of the keys, the expected key set. That's going to give me all the keys that I expect. And I'm going to check, is this key in my actual? So did my actual return a key value pair with the right key for each key? I'm going to go through all the keys and make sure those keys are in the actual. So every key has to be in there. And then I want to make sure every key maps to the right value. So I'm going to pull the actual and expected value, which is an array list of cities in this case. And then I want to make sure these array lists have all the same cities. Here's where I'm doing the checks for, I would usually put this in a separate helper method too, but I didn't in this case, is check if they're the same size, and then go over the indices, pull the values at each indice, and check if those are the same. I'm going to use another helper method, compare cities, which goes through all of the values. And make sure you're always going through all the values. I see common errors are like comparing songs after. We already wrote the compare songs helper method. We already wrote methods to compare linked lists and the like. You're expected to combine those when we get to. It was a linked list. Oh, I'm blanking, but it was a linked list of songs. I don't think we ever did a linked list of ratings as a utility method. I probably should add that. But when you get to I lost my place. When we get to comparing an array list of songs or any data structure of songs, going through that linked list of ratings as well. Make sure you're testing everything. That's a common thing that I see, comparing songs after we've already gone through the compare songs method, then either just calling that method or manually going through everything and forgetting to check the ratings. If the ratings are different, you're not rejecting those as different songs. So making sure we're going through everything, we're going through every piece of information in that file, every piece of information we have, putting that in the helper method, and then whenever I have to compare two cities, I'm just going to call compare cities. I'm never, ever, ever going through a city again and saying, get country, make sure it's what I expect. Get the region, make sure it's what I expect. Get the name, make sure it's what I expect. I'm never, ever, ever going to do that more than once. I'm going to put it in a helper method, create my expected cities, and just let the helper method take care of it from there on. Then I never, ever, ever have to worry about when I'm comparing two cities, oops, I forgot to check the longitude, and now my test case is broken because two cities without the same longitude are getting passed. I don't want to have that issue. So I write the helper methods, and I'm making that pretty clear, I think, with the testing utility methods. Okay. And then this should make sure, okay, we have the same size, the same keys, and the keys are mapping to the same values. Those values are array lists, and each array list has the same city in the same position, so order does matter in this case. All right, so that's all the provided code. Oh my goodness, we only got through the code we're starting with. Let's actually get to some live coding. So let's write this method. And there's one big thing that I want to focus on. is how do we handle multiple cities in the same country? So keep that in mind as we start this, but let's get our setup first. I'm going to get a little cute with this. For string line in files.readAllLines. So we can, files.readAllLines returns a list, and last time I showed you, I put it in an array list, and then we iterated over the array list. We don't actually have to do that. I'm going to iterate over the list directly. I'm going to use this as a list, and a list is iterable, which means we can loop over it with a for each loop, or an enhanced loop, as Java likes to call it. So I'm going to do that. I'm going to take advantage of that. Pass.get file name. Throw this in my try block. Catch my IO exception. Not even going to do anything there. I'm going to create my hash map that I'm going to return. I'll call it countries equals new hash map, and then return countries. So I got my structure. If the file doesn't exist, I go to my catch block. It does nothing and returns the empty hash map that I already created, which is what I'd want this method to do if the file doesn't exist. Just return an empty hash map. I should have a test case for that. We'd add more tests. I only have 2 test cases here. It's not good testing for this one. I probably should always have good testing when I demo in lecture. If lectures were longer than 50 minutes, I'd do that, but I have time constraints here. So for each line, and there's going to be an issue that we come up with. For each line, the first thing I want to do here is something that doesn't come up in the homework, so I just want to get this one out of the way. I have, when I do the debugging, which maybe we'll do on Friday. If we do the debugging, I have this as an example, but today, let's get through it, is that we have a header line on this file. We have a header line with all of the values, or all of the column names, which we don't have in the data for the homework, so we don't have to worry about this for the homework. But we need to handle this in some way. I'm going to say, there's a lot of different ways to do this. I'm going to say if line equals that, continue. Continue, and I mentioned this before, again, worth reminding. When I'm doing live coding, I'm in 1.16, I assume that you're at a level where you can start learning more tips and tricks. I'm going to start using some fancier stuff. Doing the loop like this and not storing this in a data structure, it's not too fancy, but it's a little fancy. The keyword continue, this is going to go to the end of the iteration of the loop. So continue means if the line is exactly this, skip the rest of the loop and go back to the top and go to the next line, the next value in this data structure. Continue, and then there's also break. That'll break out of the loop entirely and end the whole loop every iteration of it. So I'm going to use continue. I could use an else and then just put all my code in the else block, but I feel like showing off continue today. I'm just feeling continue. So continue is going to skip this header line, and then we can start parsing our line. So line, I want to start splitting it on commas. Should I use an array? No, I shouldn't do that. I won't get that fancy. Maybe I should, but string. I always call this variable splits whenever I have something I'm splitting on a delimiter. All right, do all the stuff we talked about last time. I don't feel like repeating all that. But getting that into an array list so we can work with our array list to get these values out. And then I'm going to use this header line. Conveniently, I have it right here. Usually when I'm parsing data files, I like to take a copy of a line from the data file and put it right in my method. You know what? I'm going to do that just for the sake of example. I'll grab a sample line, and I always put it right in my code where I'm parsing the data as a comment, so I can easily reference it. I'm not flipping back and forth between my code and my data constantly. So the first value is the city. I have country. My country code equals splits.get of 0. And I'm going to assume that the file is properly formatted. That's going to be the case in your homework. Everything's going to be properly formatted. So I'm not going to check if the length of splits is the number of values I expect. So I'm not safe on index out of bounds errors if the data is corrupt for what it's worth. We're not going to worry about that in 116. But I'm going to get my values at indices, string, the next one is city name, string, region, int, population, double, my brain, latitude equals splits of 4, splits of 5, longitude, there we go. And since these are ints and doubles, these are not strings, splits is going to be an array list of strings, so this is going to resolve to a string. We need to convert that to an int. Again, I'm going to assume that the data is well-formed. Integer, bless you, integer.parseInt. Let's get this stuff here. And convert these strings into their appropriate numerical values. Double is not parse int. Double is parse double. And then I want a location object. Location equals new location, lat, long. New city, city equals new city. This is one thing I don't like about Java. It's very redundant. I have to say city 3 times if I want to name my variable name city, the normal thing to name it. And then city, I have to be careful here. This is another mistake I see all the time, and I don't even understand how y'all are making this mistake. Please don't do this. The song constructor takes 3 strings. In this example, I should mention, this example is made to mirror your song and all the stuff you're doing on the homework pretty closely. Song takes 3 strings, city takes 3 strings, and then some extra stuff. Make sure you have the order of those 3 strings in the right order when you're calling the constructor and the constructor itself. The one that I don't understand how anybody makes this mistake, but I see it every semester, multiple times a semester, is your city class, your song class works. It's tested. We did that in task 2. And then when we get to later tasks, for some reason, some people will reorder the parameters in the constructor. Like, why are you ever modifying the song class? And then in office hours, I'll tell them to run their task 2 tests, and they fail. And I'm like, that's your issue. That's what you're spending hours on. I don't understand why anybody would change that after it's tested. And one thing I do recommend getting in the habit of, run all of your tests. When you're testing your code, make sure you didn't break any old functionality. You would catch something like that. All you have to do is run all of your tests every time you're testing. If you right-click your tests, I guess I don't have it here. If you right-click your test package, I could do it right here. Any package, you can run every single test in the entire package. So if you right-click on tests for your project code and click the run button, it's going to run every single test that you've written for your entire project for every single task. Then make sure you didn't do something silly like that. I don't know what possesses anyone to rewrite that class, though. Can't figure that one out. I assume it's nefarious stuff because nothing else makes sense. Okay. So I'm going to make sure, all that to say, I'm going to make sure I get the order of my arguments matching the order of my parameters. So it's name, region, country, which I purposely made different than the order in the file. Name, so city name, region, country code, population, then location. So keeping track of that, making sure we get things in the right order. Just because they're all the same type. So like Java will yell at you for most things. It'll say, well, that's the wrong type, so you got the wrong thing. But when it's 3 strings, which is why it's 3 strings, Java's not going to say, hey, you made a mistake here. You actually have to pay attention to how you're calling your arguments, how you're calling your constructor. So we're going to make sure we get these in the right order. So now we have our city, and we got to get this into our hash map. So I'm going to say countries.put country code, new array list, arrays.asList. Oh my goodness. As list. It fixed 2 errors that I typed, 2 typos I had. And then add that to my country. So I'm going through all the lines of the file, ignoring the header line, and then every other line, I'm parsing all the stuff and adding that city to my data structure in an incorrect way. And I'm going to run my tests and see what I get. So my single city, my sanity check, that's what I was looking for earlier. My sanity check test passes, so I'm on the right track here. I'm doing okay. But my other test, my a bit trickier test with multiple countries and multiple cities in one of those countries did not do so well. Let's take a look at what specifically failed. Is the size of my array list, expected 3, actual 1. So when I'm expecting 3 cities to be in that one country, I'm only getting 1 of those cities instead. So I have to fix that. And of course, this is the issue. Whenever I find a city, I'm replacing any cities that used to exist for that country, adding it to my hash map as a new array list. So when I have 3 cities in the same country, I add the first city in as that country. When I get to the second city, I create a new array list with just the second city for that country. And then when I see the third one, I'm adding a new array list with just the third city for that country. So I only end up with 1 of the cities, and I threw away the other 2. So I need a way to preserve that data. And this, let me make sure it's 100% clear, in your songs, when you're reading the songs file and the movie ratings file, you're going to have songs and movies that are rated multiple times. So there's some logic we have to add to our code to say, is this the first time we've seen this song? If it is, let's create a new song and add this rating. If it's not, let's add the rating to the existing song. Have I seen this movie before? If I haven't seen the movie before, create the movie object. If I have seen it before, add this rating to the existing movie. Have I seen this country before? If I haven't seen this country before, initialize that array list with that city. If not, I'm going to pull the array list that already exists for this country and add the city to that array list. This is probably about half of the difficulty of task 6 is handling this situation. Have I seen this song before? Have I seen this movie before? And accumulating all of the ratings for the same song or movie into the same object. The other half is testing your data structures when the order doesn't matter, if you're wondering what the other half is. So we need some logic here that says, if I've seen this city before, have I seen this city before? For that, we have a very handy contains method. Contains key. Does this country code exist as a key in this hash map? If it does, I've seen this country before. I'm actually interested in the negative of this. So if it doesn't exist, I have not seen this country ever before. And I'm going to do something called lazy initialization here, where I'm not going to worry about... What am I trying to say? I'm only going to initialize the array list at the last possible moment. So I'm not going to do any pre-initialization. I could go through this file, find out what cities I have, and create an empty array list for every city, then go through the file again and populate all my array lists, all my empty array lists. I'm not going to do that. I'm going to only initialize the array list when I first see a country. So if it's the first time I've seen the country, I'm going to go to my map, and add an empty array list for that country. I'm going to lazily initialize the array list for this country, and I'm only initializing it. Now, we know at this point that this city needs to end up in this array list, but I'm not even going to worry about that. I'm just going to initialize the array list. And you can do this, if you do this different, I don't care. I'm just showing you how I like to do it. I like the lazy initialization method. Because now, whether this code ran or not, I don't care. I don't care if we just initialize this array list or if I've seen this country 100 times and I have 100 cities in this array list. I don't care. As soon as I get to this line right here, I know that this country has a key in the hash map that maps to an array list which may or may not be empty. I don't care if I just created it or not. I know it exists. So I can get that. I can go to my country's hash map, get an array list by country code. I know that array list exists because my previous conditional created it if it didn't. So it has to exist, or else I never would have made it to this line of code. It has to exist. So I can guarantee that exists. I'm not going to get a key not found error. I know it maps to an array list, which may or may not be empty. I'm just going to add city to it. So now I don't really have two separate pieces of logic for, did I see this city before, did I not see this city or country? Did I see this country before, did I not see this country before? I have one extra clause which says, if this is the first time we've seen this country, initialize it. And then after that, whether we've seen it before or not, we're going to do the same exact thing. So it cuts down on the code. It's not a huge optimization, but it cuts down on my typing and my brain power I have to put into thinking about something like this. If I have an if, for example, if I have an if and then I add arrays.asList city right here and then an else, and I do something completely different in the else, I don't know, just more taxing on my brain. Anything I can do to make my things easier for my brain, I'm going to do it. We're programmers. We're as lazy as we can possibly get away with. That's what we want to do. If we weren't lazy, we wouldn't be training computers to do our work for us. So we're adding that city, and I'm paying attention to my references too here. When I get an array list by country, this resolves to a reference to an array list that lives on the heap. So if I'm going to that array list on the heap and calling the add method, I'm adding the city to the array list, and I don't have to update my hash map at all. My hash map maps strings to references, and they're always going to map to the same references, no matter what. I'm going to go to that reference and add something to that array list and not go back to my hash map. I don't have to put back into my hash map. Where, for example, if this were a hash map of strings to ints, if I was just counting the number of cities in each country, I would have to do countries.put of country code, country.get for the country code plus 1, which is a little more cumbersome. Here, since I'm paying attention to my references, I don't have to do that. This method's done. I'm done, baby. Test it. Test passes. We handled that multiple countries, multiple cities in a single country. We can add more testing, but I'm pretty confident that this code's fine. This code's working good. So have I seen this song before? If not, initialize it. If I have seen it before, pull the song by ID, pull the object for that song, and then add that rating to the song. And I do recommend using a hash map for the songs when you're iterating through those for songs and movies. Use a hash map that's going to map the ID, anything that's unique, the ID to the song object, and do this same pattern. And then when you get to the end, since you have to return an array list and not a hash map, get all the songs out of the hash map, stuff them all in an array list, and then return it. That is my recommended approach for the songs, if you're wondering. Okay, any questions on any of that? No questions in chat. Oh, there are questions in chat. Ooh. That is not appropriate. How do we update the class code repo on IntelliJ? it won't update with what I'm coding here, but what's in the repo, like for the start of this lecture, I deleted the code that's in the repo, and now I'm just recreating it. It'll be slightly different than what's in there, but if you ever want to update the code, I don't think I've pushed in a while. You click this button. I didn't push Mondays, like I wrote that one method. I didn't push that one. So any other questions on this? What happens if I add my cities to the front of the array list instead of the end? Is this code wrong? And remember, if I give two arguments to the add method, the first one is the index that I'm inserting to, and the second one is the value I'm inserting. So I'm adding, effectively prepending instead of appending. But the same stuff, I'm returning the same data. Is this wrong? And what does wrong mean? Well, if we want to know what wrong means, we look at the description. Does the description say anything about the order of the values? And of course it doesn't. So this is returning a correct answer. It's returning the right data in the right data structure as specified by the description of the method, but my test is failing it. This is something we have to handle because we're taking a correct solution and saying that it's wrong. And this is a big part of homework task 6 is it's the utility method. All the methods have this feature where the order doesn't matter of the return values. So whatever's returned, we have to make sure it has the right stuff in it, and they're all arrayless. We have to make sure it has the right stuff in it, but in any order. So we have to have some way of handling this. So in our code here, where we're going through indices, we're going through each indice of the array list and making sure it has the same values at each index. We need to do something different here. I'll leave some of it up to the homework. I don't want to give the whole solutions, but I'll give at least the idea here. We still have to check the size. If they're not the right size, we're completely sunk. But for each value in, and maybe I will just end up giving it away, for city in expected cities, and here it's definitely important that I iterate over my expected cities, because I can't trust anything about the actual cities. Whatever's actually returned by the method that I'm testing, I can't trust anything about that, because we don't know. It should be treated as completely toxic. Anything we touch with that, it can't be trusted. We have to assert that it is what we expect. We can't assume anything about it. A lot of you learn this in task 3 with linked lists. You make assumptions about what's returned, and you start getting null pointer exceptions. And you get errors in Autolab, and everything breaks down. Can't make any assumptions about it until we assert it. We asserted the size, so we know the size is what we expect. But now we have to check if the cities that we expect are in there. So for each city we expect, is this city in the data that was returned? City expected city. And we need some unique identifier. For songs, it's going to be the ID. Actually, I think I just said title is fine for everything when you get to task 6. I don't have any test case where titles are identical, so even if I didn't put that in the document, titles are going to be unique for those, for movies and songs from task 6 onward. For task 7, I definitely said titles are unique. But the titles are going to be unique. Let's just, for the sake of argument, oh, that's not true, but just for the sake of argument, we'll say that the names are unique. So if city.getName equals expected city.getName. So if the names are the same, then we can compare these cities and make sure that they are the same. I got to make one more point because you'll run into this. Then we'll make sure the cities are the same. And we have to do something else. This one I'll leave up to you. Something else to know if we got to the end of this loop but never hit this conditional, we need to say, well, we didn't find any cities with that name. So with this code right here, if the two array lists are the same size, it's going to say, yep, we're good. As long as they're the same size and there's no cities with the same name and different other values. So we have to make sure